File transfer word problem. Agent Hunt transferred classified files from the CIA mainframe onto his flash drive. The drive had some files on it before the transfer, and the transfer happened at a rate of 4.4 megabytes per second. After 32 seconds, there was 384 megabytes on the drive. The drive had a maximum capacity of 1,000 megabytes. First question. How many megabytes were already on the drive before the transfer? Now, I encourage you to solve both of these problems before we go over it together. Okay, so let's go and highlight some of the important information that was given to us in the problem. So Agent Hunt is transferring classified files onto his flash drive. So the drive had already had some files on it before the transfer. And the transfer happened at a rate of 4.4 megabytes per second. After 32 seconds, there was 384 megabytes on the drive. The drive had a maximum capacity of 1,000 megabytes. So the important key part over here is that the drive had some files on it before the transfer. So we're trying to find how much megabytes were already there on the transfer. So we can give that the variable x. So I'll write let x equal number of megabytes. I'll write MB for megabytes before transfer. Okay. So x would be on one side of the equation, and then on the other side we'll write the formula of how to solve for x. So how we can find x? As first, we take the whole, in this case, 384, because we know that x has to be part of 384. And to solve for x, we need to minus 4.4 times 32. Why? Well, because this is total, at least in this case, and this 4.4 times 32 would be MB transferred. So how many megabytes that were transferred during the transfer? So it would be the total minus the ones that were being transferred, and that would equal the ones that were already on there before the transfer. So how we solve for this is x is equal to, we use the order of operations, so 384 minus, what is 4.4 times 32? Well, 4.4 times 32 would be the same as 32 times 4 plus 32 times 0.4. So this would be 32 times 4 would be 128, plus what is 32 times 0.4? 32 times 0.4 is 12.8. 12.8. So you add them together and you get 140.8. So x is equal to 384 minus 140.8. And then after you do the math over here, it would equal 243.2. So this over here, x is equal to 243.2, and the answer to the problem would be 243.2. Okay, now take a good look at the screen. Make sure you know every single bit of how we did this. Then we'll move on to the second problem. Okay, so what is the second problem? The second problem is, how long will it take for Agent Hunt to fill up all his contents in the drive? Let me just quickly finish erasing this. Okay, so this is asking for how long will it take for Agent Hunt to fill up all of his contents. So we already know. Let's first set a variable for this. So the variable we could set as the answer to this question, how long it will take for Agent Hunt to fill up all his content in the drive, is equal to the variable y. Okay, let's make that y. So y is equal to, well, how do we write this equation? We're finding out how long. So first, we need to know what is the total distance. Then we divide it by the rate, then we'll get the time. Remember the equation, distance divided by velocity is equal, or you could do speed, is equal to time. So what's the distance? Well, it's for, right now, when it says for Agent Hunt to fill up all of his content in the drive, it's not talking about the 243.2 megabytes that was already there. And yet we know that it has a maximum capacity of 1000 MB. So we can write the equation as, at least this front part, 1000 minus 243.2 MB. And this part will be the distance. Okay. Then what we're going to do is divide it by the speed he's putting in the megabytes. I already said that it was 4.4 megabytes per second. Okay, so divided by 4.4, that's the speed, and y is the time. So now all we have to do is solve. Y is equal to 1000 minus 243.2. And then 756.8 divided by 4.4 is 172. So therefore, the answer to the second problem is y is equal to 172. So 172 seconds. Remember the unit there. So how much megabytes? You're supposed to write megabytes, but I'll write MB for short. So thank you for watching this video, and we'll be going through some more of these linear equations later in the next few videos as well. So what was important here was identifying, for the second problem, what's the distance, what's the speed, and what is the time. And for the first problem, we needed to be able to find out, we need to be able to visualize that the number of files, number of megabytes before the transfer would be equal to the 384. We had to think of that as the total divided, minus 4.4 times 32, which was the number of megabytes on the transfer. So it was important to visualize that, and I'll see you next time.